Alright, appears to be a recording being made. Alright, so in my recommended videos, on a video I was watching, this came up. And I watched about whatever, I don't know, 30 seconds, 20 seconds. It's just like, oh, it just starts with such a pile of nonsense that might as well demonstrate how professionals, people who are supposed to know what they're talking about, this is how they explain their subject. It's with a bunch of just made-up nonsense.
In fact, Richard Feynman, who won the Nobel Prize for his work on quantum electrodynamics, said, if you think you understand quantum physics, you don't understand quantum physics.
Yeah, he said a lot of things, and his whole point is that there's no way to understand his theory of quantum physics, right? I mean, his theory isn't Copenhagen, it isn't many worlds. His theory is randomness just happens, okay, by the random angels. So obviously he's saying, who can understand that, right? Who with a practical, logical, cause and effect mind can understand something that's not cause and effect? That's what he's plainly saying. It isn't understandable, so don't try to understand, just do your mathematics, because we just don't really care about causes and effects, we just care about effects. And it doesn't matter what kind of angels we make up to be causes. As long as we get the effects right, we're in business. You don't need to understand causes, right, to build a campfire.
Which is kind of disheartening for us, because if he didn't understand it, what chance do the rest of us have? Fortunately, this quote is a little misleading.
No, it's not misleading. It's the actual truth. There's no way to understand the fact that 1/3 of physicists think it's Copenhagen, and 1/3 think there's new universes being created, and the other third goes with some compromise of whatever radartons. You know, you have no hope, because the physicists are just obviously confused. Feynman didn't believe, he didn't sell the Huygens theory because he didn't think it was right. He didn't think photons were waves. He thought they were corpuscle, clumps. He kept calling them that. He made it clear, the thing don't work that way. And yet you're pretending that, oh, they had this great coherent understanding. No, there's no coherent understanding. It's a totally uncoherent understanding. Virtual photon, borrowing from a vacuum. These are concepts that can't be understood as reasonably accurate descriptions of reality. They're unreasonably silly. And here you are selling it like, oh no, we have a tremendous pile of logic behind all this nonsense. No, you don't have any logic. You have desperation. That's why you invent the dark matter. It's because you're desperate.
In fact, understand quantum physics really well. In fact, it's arguably the most...
Yes, no, he didn't understand it really well. He said it plainly, okay? I just do math. I just do my little clock thing. I know that, you know, it all has to do with distance and time, and, you know, there's angles that come out in the end. And that's what he understood. It's angles that come out in the end. Jesus, you're just such liars. I mean, it's just lying. I mean, to imply that Richard Feynman didn't mean what he said. No, he meant it. If I can't figure it out, you can't figure it out. He was saying it plainly. Give up, okay? I'm super smart. I can't figure out how this crap works. You have no chance. He was saying it clearly.
Most successful scientific theory out there.
Okay, the most successful scientific theory. Just an absolute pile of crap. Again, you know, like quantum mechanics was understanding the fact that it is actually random, or that it is actually Huygens, or that it is actually Copenhagen, or that there's actually new universes being created, that somehow that knowledge, and that's quantum mechanics, that there's virtual stuff doing virtual things, well, anybody can make up that, so that's nothing. Again, it has nothing to do with the modern world's technology. Again, you don't have to understand the chemistry or the physics of fire to build a campfire. You really don't. And in history, that's how it worked. Okay, we figured it out by effects. We didn't figure it out by understanding causes. I mean, you're just such liars. I mean, just this next scene. It's just so typical of these liars.
and has let us invent technologies like computers, digital cameras, LED screens, lasers, nuclear power plants.
Right, none of these things had anything to do with quantum mechanics, okay? Nuclear power, no frickin' way. The Curies didn't bother with any of that nonsense, let's understand. Nuclear bomb, you don't need any quantum mechanic knowledge to understand that if you consolidate a bunch of unstable isotopes in a small mass and then you implode it, that it's going to explode. No, you don't need any quantum mechanics for that. All of these devices, the photo detector, it was basically started with the first Einstein experiments with bouncing electrons off of metals. That was already your first photo cell. So this is just such nonsense. Has nothing. You don't need any knowledge of randomness. No, you don't need to know why is it happening. No, you just need to know what happens, and that's all. You don't need a theory of why it happens. And quantum mechanics is a theory of why it happens. Again, isn't even one theory. It's like 14 different theories. Depending on what physicist you ask, you'll get a different answer about what quantum mechanics actually is. I mean, this is just such crap.
No, you don't really want to build a nuclear power plant if you don't really understand how it works.
Oh yeah, no, you can do it without understanding how it works. Again, just like you can build a lot of things without understanding all the dynamics. You don't need to know a whole lot about exactly how heat and pressure and all that stuff to build an engine. You don't need any of that knowledge. You just need to understand that, okay, the way I have it now is it gets too hot. So how can I make it less hot? That's all you need to understand is why is it not working and what can I do to make it work. And that's how everything got invented. Everything.
So quantum physics is the part of physics that describes the very smallest things in our universe. Molecules, atoms, subatomic particles, things.
And virtual things. Virtual this, virtual that, made up this, made up that. So let's not pretend it has anything really to do with electrons and protons. We already know that neutrons are just a composite particle. Okay, the structure of the atom, we know the basic outline, protons in the middle, electrons on the outside, not too complicated. Molecules, we know the basic idea, they share an electron. Now you wacky people think the electrons are flying around in figure eights and in loop-de-doos and in fake orbits and all that crap. But it doesn't really matter what way you think about it, as long as you get the fundamental part, which is, oh, it's shared electrons. Does it really matter how you understand how they're shared? Probably not. But the fact is, I think your theory is wacky. It can be proved to be wacky in the sense that you'd never be able to bond atoms together with these electrons that are in all the places at once kind of nonsense theory, because they're not in all the places at once. It's just silly.
Things like that.
You give magnetic moments to a negatively charged particle. So a negative charge, essentially the magnetic monopole, an electron, and people will talk about its magnetic it's a dipole moment. It's not a dipole. How can I have a dipole moment? It's not a dipole. I mean, you people can't get anything right.
The things down there don't quite work the same way that we used to up here. This is fascinating because you and everything around you is made...
Yes, and that's something you people don't even understand, because you think all particles obey Newton's laws. So you think an electron and a person are the same thing, and if I give one velocity, it'll keep velocity. Well, it doesn't. Go shoot some electrons in space and see how far they go. Go shoot some protons in space and see how far they go. And maybe you'll find out that, hey, for some reason, they don't go so good. They don't just keep flying. I wonder why. Have you ever asked the question? No.
From quantum physics. And so this is really how the whole universe is actually working.
So this is how it's actually working. And again, it's going to be full of mumbo-jumbo about a virtual thing. Okay, a thing that they can't label it, they can't call it something, but they have no accounting for where it came from, where the energy comes from. So they have to call it a virtual photon, just as they had to call it bent space, because they didn't account for actual force, an actual mechanism, actual physics. So this is supposed to be real physics and doesn't have anything physical in it. It has bent things and virtual things and dark things. Yeah, it's that bad. They call it physics, and it's made out of bent nothing, okay, virtual something, and dark, invisible stuff. And that's called physics. Bullshit. Silly nonsense.
I've drawn these protons, neutrons, and electrons as particles, but in quantum mechanics we really describe everything as waves.
Right, because some of the stuff has a frequency, or it's actually vibrating, or it's actually in tension. So, I mean, quite obviously the atoms are connected to each other, and if you jiggle one atom, it jiggles the next atom, it jiggles the next atom. And obviously if you send a force in some sort of cannonball manner and you hit that jello of atoms, then yes, the impacts will be recorded as a movement of vibration through the medium. Yeah, it's not a big huge surprise that stuff will be moved in periodic fashion. Things will get poked. Okay, but that doesn't mean it's a wave. Okay, the actual physical world underneath everything, you gutless cowards, you sit there and are essentially pretending there's an ether, okay, but you won't say the word. You won't say, I believe in ether, because that's the only way your electron could have any wave properties, isn't it? How can a photon wave? What is it waving through? Where's your proof or evidence that there's anything called a wave? Oh, that's right, you don't have any evidence of that. You have an evidence that when photons hit electrons, they're changed in their direction. That's what you have evidence of. You have an angle formula, not a wave formula. This silly obsession with silly waves, you know, is just completely your retard fall. I mean, it's absolutely no reason to commit yourself to it. Absolutely no reason to go with some idiotic duality. It's a problem sitting right there in front of you saying, resolve me, and you all cowered out because Feynman said, I can't figure out this distinction, and Einstein said, yeah, well, there is this stupid wavy thing, and there's this clumpy thing, and well, sometimes it's a clump and sometimes it's not a clump, and blah, 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 blah. Because he compromised you all, and he didn't compromise willfully. He only compromised because nobody let him come into their sports clubs and play handball with them if he didn't sit there and play along with everybody else. I mean, it was literally, I think, tied up and beaten with a hose and told, you must comply.
By the way, I'm using quantum physics and quantum mechanics interchangeably. They're the same thing.
Oh, yes, whatever that means, right? So the idea of a quantum, the idea that it comes in clumps, as Feynman would say, right? Not waves, but clumps. So quantum, why don't you just call it what it is, your wave mechanics, okay? You don't give a shit about the idea of quantum. You're wavical people, you're ether people. Call yourselves what you are. Why don't you just be honest? Why don't you just grow some integrity and say, yes, I believe in the magical jello.
So instead of...
I mean, really, they think there's something. A photon, the simplest thing in the universe, goes in dead straight lines, travels billions of light years across space in a dead straight line. And they're sitting there saying somehow it's vibrating a bunch of jello as it moves. It's moving in the up. Some magnetic field is vibrating, and some electrical field is vibrating, and everything's vibrating. But nothing can sense the vibration until the photon actually hits the target, right? You can't tell the photon is there in any way whatsoever. It's completely invisible to anyone's perception unless it hits an electron. And yet they're pretending it's doing all this stuff. Zero evidence that there's any field perturbated by a photon except the field of the electron when it plows into it.
Instead of an electron looking like this, it should look something like this. This is called a wave function.
Oh, amazing. Yeah, this is called a wave function. Right now, like I said, Feynman didn't believe it, that a photon was a wave function. He believed it was a probability. That's what he believed, okay? That it had a probability of being in one point or another point, and that's all he believed. He never accepted any idea that it's a wave function.
But this wave function isn't a real physical wave, like a wave of water or a sound wave. A quantum wave is an abstract mathematical description.
Right, so it's absolute nonsense. So again, you're saying, here, I have the right answer for you. We do understand it. It's an abstract mathematical function. There's your understanding. Don't you understand it now? See, we do actually understand quantum mechanics. It's not physically real. It's an abstract mathematical wave. It's a tool, a mathematical tool. The universe is made out of mathematical tools. Don't you understand? We're not trying to describe reality. We're making reality up on a piece of paper by drawing some stupid symbols on a piece of paper. That's what reality really is. It's just symbols on a piece of paper. pathetic. We understand. No, you obviously don't understand. You wouldn't write crap like this. It's not physically real. It's an abstract mathematical, convenience, contrivance. Reality is an abstract mathematical contrivance. That's what he's saying. I understand reality. It's an abstract mathematical contrivance. Is that what somebody says who understands? Somebody who understands use the words abstract? Yeah, I don't think so.
Get the real-world properties like position or momentum of an electron, we have to do mathematical operations on this wave function. So for the position, we take the amplitude and square it, which for this wave...
And again, you're not getting it. So again, this just is another lie, right? Oh, we can know its position and its velocity. No, you can't. So all you can do is say, well, it's somewhere around in here probabilistically. Right? It could be on Venus, okay, but it's not... That's really unlikely, okay? So like the 99% probability is this big, okay? And then the 1% probability, yeah, that's over here, you know, and then the 0.000000000000001% chance is it's on Venus. You don't answer any question, okay? You're just sitting here describing the effect. Well, it's moving really fast and we can't take a photograph of it, so we'll have to just approximate its location because it could be affected by something on its travel. And we know in the double slit experiment, for example, that there's no wave interference crap happening. The effect happens right from the very start, right from the slit. It's already heading where it's going. That's why I can move the target as far away as I want to or as close as I want to. And, you know, there's no interference here. It's heading in a direction, period.
Wave would look something like this. This gives us a thing called a probability distribution, which tells us that you're more likely to find the electron here than here. And when we actually measure where the electron...
Right, and that's just describing an effect. So everybody can do that. Everybody can go to Las Vegas, they can stand there and watch the roulette table, and they can say, hey, there seems to be an equal probability that the little ball falls at any one of those holes. Gee, this is what the wave looks like. It's even. Yeah, there's the same chance for every single little notch. Gee, I'm a genius. I just did quantum mechanics. That's all this is. They watch something and then they say, hey, there's a probability there. Let's draw a little bit of an equation or a squiggly line to describe that probability. That's all they're doing. They're just describing effects. They're not explaining why it happens at all. And when they attempt to do that, they come up with silly nonsense like, well, Huygens says that when, you know, waves go through an open slit, they break in two and create two waves that interfere with themselves, and then they land in one location because they got lonely, or some other kind of bullshit. I mean, it just gets silly. It just turns into some silly witch gingerbread bullshit story. And again, this guy's selling this like somebody with some sort of logical intelligence, some sort of reasonable understanding of the world is going to, oh yeah, that's perfectly acceptable. No, they're just talking to idiots who have for thousands of years believed in stupid idiotic gods and still do. And they're basically just giving them another silly god story, okay? This is just full of holy ghosts and witches and demons and, you know, Goliaths and dragons. This is just another silly story to sell to silly frickin' people. You're all intellectual frickin' goddamn fairies, you know, midgets.
Electron is, an electron particle pops up somewhere within this area. So with quantum physics, we don't know anything with infinite detail.
Right, you don't know anything with any detail. Not infinite detail, any detail. Right, you're just doing this obvious thing of saying, gee, I threw the ball in and I couldn't figure out all the variables, and this wheel's spinning really fast and I couldn't figure out which hole it was going to fall in. Duh. And you're pretending you're doing something more than just accepting the fact that, yeah, I can't understand all the variables. It's a little too complicated. Too many bounces. I can't tell you where the ball's going. You know, the wheel's moving way too fast, bouncing way too much. Can't tell you. And then you're pretending you actually did predict it. I'll just predict it'll fall in one of those holes. There. Aren't I brilliant? Look, it fell in one of them. Isn't it amazing? I predicted that. Isn't my theory so freaking brilliant? It predicted the ball would fall in one of the little notches. Wow. I'm so smart. Oh, this is so pathetic. That you people fall for this crap. The little wavy thing turns into a little particle, and then a little particle goes somewhere. I mean, what is that? It's just a baby story.
We can only predict probabilities that things will happen. And it looks like this is a fundamental feature of the universe, which was...
Oh, I know. It only looks like it to you. So why don't you just say, oh, I have accepted that there's the God of probability, and he is not allowing cause and effect, and he is saying, no, I'm going to just randomize things. I'm going to hit that little ball with my finger. So the roulette wheel is spinning around, little God is just hitting it with his finger. And so I guess he's just doing it for fun, so he hits it just in all directions at equal amount, so it never screws up the probability, so you never have any ESP or any magical powers or any of that stuff. Except when you get to your entanglement, then you can have magical powers. I mean, what's the point? Oh, I'm going to randomize something that's already fucking random. Oh, brilliant. Yeah, randomize the random thing. Gee, that's so smart.
It was quite a departure from the clockwork deterministic universe in classical physics, the kind of thing Newton derived.
Oh, whatever. Newton was just as confused, so don't pretend that Newton had any preference. He was just sitting there saying, I don't know what's doing it. I don't know what's causing this. I have no idea. And again, let's understand, he's the one who discovered it. I mean, he's the one that discovered the Newton's rings, which is the diffraction pattern, which is your interference pattern now. Okay, he's the one that discovered it, and he obviously didn't have an answer for it.
This wave function model predicts what subatomic particles will do incredibly well. But
Yeah, any model will predict what it does very, very well if I just contrive the circumstance that causes the effect. So I can just make it into an electron theory, and I can give you certain rules about how the electrons are aligned in the slit, and then explain why there's a probability that the photon will end up at a certain angle. Because all this is about, all this interference pattern is created by, right, something that we have no evidence, we can't make photons interfere with themselves. You don't have any consistency, again, in your theory. Okay, for the interferometer, what are they different photons that are interfering? In the radar experiment, two-slit radar experiment, we have two guns. What's the theory? How did the photons get turned into wave functions? They don't go through a slit. They don't Huygens. So how did they get turned into a wave function? So are the individual different photons interfering with each other? So what's your theory? Do a single photon split into wave functions and interfere with themselves, or is it multiple photons can interfere with each other? Even though we have no evidence of that, because every time we try to make photons bang into each other, we can't make it happen. There's no consistency in this drivel.
But weirdly, we've got no idea if this wave function is literally real or not. No one's ever seen a...
Yeah, so again, he says, we do understand, right? He started this video by saying, we do understand. And he's just right here overtly in front of us saying, we have no clue. We're just making up some kind of basic, whatever we can get away with. See, it's so complicated, it's so tiny, this universe, that we can make up any kind of nonsense fable about how it works. We can put gremlins in it, and we can put spooky bits, and we can put, turdy bits, and we can put tall bits and little bits, and skinny bits, fat bits. We can just make up all kinds of little cookies and crayons, and nobody's going to be able to test it, because nobody can see whether it is cookies and crayons. So, yeah, no one's going to be able to prove us wrong. The problem is that does it make any, does it have consistency? And clearly Huygens doesn't have any consistency. A photon breaks in two when it goes through one slit. Then when it goes through two slits, it only breaks into two. How come it doesn't break into four?
A quantum wave, because whenever we measure an electron, all we ever see is a point-like electron particle. So there's like...
Well, I don't even know why you're even talking about electrons, because of course they're point-like particles. If they're shared by atoms, it doesn't make any logical sense to think of them any other way. Clearly, for so much of what atomic theory is dependent on, the whole idea of having a magnetic moment of an atom sort of requires that the electron not be a stream of stuff that's going all over the place. To have a moment, it's sort of the clump has to be in one location on the atom's surface. I mean, you know, that doesn't take a brain surgeon. To have paramagnetism, you obviously have to have some idea that something goes to one side and something goes to the other side to create the dipole. I mean, you know, it's just obvious.
Like this hidden quantum realm where the waves exist, and then the world we can see, which is where all the waves have turned into particles.
Right, so we understand, except we're going to make it red and blue at the same time. We're going to do this duality bullshit. Complete, absolute nonsense. It's either one, the other, or neither. As is with quantum mechanics and relativity. It's one or the other, or neither one of them are the truth. And the truth is neither one of them are right. Neither one of them explain the energy for gravity. Neither one of them explain the energy for magnetism. You got the wrong theory, you got the wrong idea, you got the wrong, you called it a pixie and it's a gremlin. And you just got the wrong behavior. You got the sheep watching the herd of wolves. You know, you got it so backwards.
And the barrier between these is a measurement. We say that a measurement collapses the wave function, but we don't actually have any physics to describe how the wave collapses.
You don't have any physics demonstrating there's any wave in the first place created. So again, where is it a wave? Where is it a wave function? So now you're using the word wave in two ways. You just explained how, well, mathematically we understand it as a wave function, but it has to be turned into a wave function. It can't just be a wave function without being turned into a wave function.
This is a gap in our knowledge that we've dubbed the measurement problem, and this is one of the things that Feynman was referring to with his quote. Another confusing thing is how exactly to picture an electron. It seems to be a wave until you measure it, and then it...
So again, it keeps talking about electrons, which have no wave properties whatsoever. De Broglie completely just made up a concept saying, well, look, there is a similarity between frequency, okay, and what you might say the strength of a photon. And so let's make a correlation, you know, so we call that momentum in a sense. So if I have a bunch of little cannonballs really close to each other and then I have cannonballs far away from each other, there's an obvious difference there. You know, the 10 cannonballs is more than 3 cannonballs. And so because there's that correlation, I'll just make up this fact that, okay, because electrons can have momentum, that is, you can move them at variable speed. See, the photons, you can't change their speed. But the electrons, you can change their speed all over the place. And so by changing their speed, you can change their momentum. And so now they just made this silly correlation. And we said, well, let's call momentum, okay, frequency. Okay, because frequency is associated with momentum in photons, energy. Let's pretend that the energy of the photon, of the electron, is a frequency. When there's no frequency, it's moving a speed in a direction, no frequency involved, and we'll just pretend they're the same things, and we can mathematically do that. There's no rule against mathematically doing that. Just like I can recognize kilograms or pounds per square inch as a description of the force of gravity. So instead of doing it in newtons, I can do it in pounds per square inch. So I can just say that gravity causes the mass to become a certain weight in terms of its velocity will cause it to make a bigger hole in my hand. Because it has more mass and velocity and momentum. And so I can play the same game and turn momentum and just measure it as pounds per square inch. We can all change what you use as a constant, and what you use as a what's the right word for it? As an amount. I just can't think of the right word for an amount of something. And they already do that in physics. It's all over physics. They have literally 17 different ways of describing a clump of energy. I mean, it can be a calorie, it can be a Kelvin, it can be a horsepower, it can be you can think of some of them. There's a whole bunch of them.
It's a particle.
A
so
what?
What actually is it? This is known as particle-wave duality, and here's an example of it in action. The famous...
Okay, so wave-particle duality. So you can see they don't understand. He's just going to show you exactly how they don't understand. And he said in the beginning of the video, oh no, this isn't hopeless. No, you have a hopeless theory. because you have a wrong perception. Again, this whole stupid wave crap is just wrong, wrong, wrong. And as Feynman directly stated, so again, they're using Feynman as an example. This is just like these idiots using Einstein for this stupid gravitational waves when Einstein didn't believe it. I mean, it's just such a lie to put Feynman's face on this crap, okay? Because Feynman clearly doesn't believe this crap.
This double slit experiment. Imagine spraying a paintball gun at a wall with 2 openings in it. You'd expect to see 2 columns of paint go through and hit the wall.
Yes, and we know that fucking nuclear particles aren't paint. So again, it's always back to this lunacy where we're supposed to expect that the stuff operating on the tiny micro universe, where there's actually 2 things, electrons and protons, and they're both charged, which is a fundamentally different character they have. I mean, they're exactly opposite in their character. And we're supposed to believe that that universe, where the photons interact between those 2 particles to create the virtual photons, whatever, the photons interact with those, the virtual or real photons interact with those 2 particles, and we're supposed to be, oh yeah, the correlate to that is blobs of paint. No, it isn't.
Behind. But if you shrink this all down to the size of electrons, you see something quite different. You can fire 1 electron at a time at the slits, and they appear on the back wall. But as they build...
So again, he's using the electron example. Now, why isn't he using the photon example? And why don't you use the single slit, the 350-year-old experiment, the one long before Young? Why didn't you use that one, Newton's? Because yes, then you'd have to concede that this is doesn't have anything to do with this crap, and you haven't resolved a question that exists when Newton and Huygens actually existed. The question was still unanswerable.
Build up over time, you get a whole pattern of stripes instead of just 2 bands. This pattern of stripes is called an interference pattern.
So he's conceding they're stripes, all right? So he's not conceding what they're supposed to be, which is this gradual on and off pattern. Yeah. But electrons actually do have that look, but of course, because they're electrons, they're charged bodies bouncing off of charged bodies, which means they never really hit each other, they deflect off of each other. So of course the electron pattern looks like the mathematics says it should, where the photon pattern doesn't. So is that why he's not using the photon pattern? Because the photon pattern actually doesn't match the mathematical prediction. The prediction isn't perfect, it isn't even really close. And again, what is the prediction? The simplest pattern in the universe. On, off, on, off, on, off. Simplest pattern in the universe. And we're supposed to always believe it can only be caused by one thing. Magical wave interference.
Thing you only see with waves. The idea is that it's the electron wave that goes...
You only see in waves. This here, I'm just saying, right? So if there's ever an on-off pattern, you know, if I go over to my light switch, turn the lights on and off, I'm waving. It's wave interference. Woo! No, it isn't. It's just an angle. 3 degrees, 6 degrees, 9 degrees, 12 degrees, 15 degrees. That's all it is. The same angle repeated n number of times. That's all it is. It's that simple, and it finally runs out of particles as it goes further and further away, right? So there's obviously some kind of correlation, like somehow not as many photons do that really big bend, but lots of photons do a little 3 to 4, 6, 9 degree. Yeah, lots of them do that, but then they start to not do it too much. So maybe there's a reason that when you make the slit smaller and smaller, there's fewer and fewer things it can hit to be deflected. Duh.
Goes through both slits at the same time. And then the waves from each slit overlap with each other.
Alright, so now we have the new version. We don't even need straight waves. We'll put crooked waves in. So they usually do this plane waves going in thing, which was always a lie because they always put the light through a small aperture in the past. But anyway, and so yes, we're supposed to believe that these photons went through both of the little slits, and then they somehow turned into these, some other kind of photon, a waveaton. And the waveatons interfere with each other and then do some calculus and then figure out, oh, I should be over here at 9, okay? Oh, no, maybe I'll go back to 6. No, I don't know. And it's supposed to be, you know, particle plus particle equals no particle here, right? So clearly that energy has to either go to the right or to the left. They don't have any theory about how it decides which way it's going to go, though. None at all.
Where the waves add together, you've got a high probability of the electron popping up at the wall, but where the waves cancel out, the probability is very low. So actually on the back wall, the highest probability of finding the electron is in the middle of the slits. And then it goes down, and then up again, and down, and up again. And this is the interference pattern.
Yes, well, the slits are tiny compared to the target, so let's understand that that middle clump, the slits are 1/1000th of the thickness of the target. So the band on the wall is 1,000 times wider than the slits are. So obviously the fact that there's a little impediment in the way, a hair or something, well, obviously that hair is going to be meaningless in terms of blocking any of the light. You'd never even see it. If you could make a shadow, you couldn't see it. But if you actually do change how far away the target is, you'll actually be able to see the little slit in the middle. You'll actually see the shadow. At the right focal length, you'll be able to see the shadow. But it's still there at the distance. It's just it's been blended out by the diffraction. Jesus. I mean, Jesus.
So when you fire one electron after another, they follow this probability distribution, and this interference pattern starts building up, and that's exactly what we see in experiments.
So again, do it with photons. One little photon. One photon goes through both slits magically.
This shows that electrons behave like waves in this experiment. The question is what actually happens to this spread out electron wave when you do a measurement. It seems like it goes from this spread out wave to this localized particle. But like
measurement means you let it hit the target, okay? So why don't you talk about detecting and how, oh yeah, that's right, we can't do that.
Like I said, there's nothing in quantum mechanics that tells us how the wave function collapses.
Right, so there's nothing in quantum mechanics that tells us anything, like why doesn't it create 4 waves? If one slit creates 2 waves, why doesn't 2 slits create 4 waves? I'll never get an answer to that question, of course.
And this is not only true for electrons, but everything in the universe.
Oh, so more just nonsense. It isn't true for everything in the universe. Just babble made up. The pattern gets worse and worse the bigger the thing you're using, because the only thing that's making this happen is the stuff near the slits, the actual matter. So again, they're pretending the photon that's a million times, billion times smaller than, say, the atom. They're pretending that the photon has all these powers, and then but the atoms that are making up the surface that are mostly empty space. Let's understand, atoms are mostly empty space, and they're lining on that surface there, and there's a bunch of free electrons that are kind of, they're outsiders. They're not really part of the atomic structure. They're just floating around saying, I'm attracted to the proton, but those electrons hate me, so I can't get too close. So they're just like, voyeuristic electrons just hanging around looking in the window. Is covered in any material object. Any material object is literally covered with a bunch of loosely associated electrons. And they're just pretending they don't have any place in this universe at all. They don't do a single thing. No, they could never possibly interfere with a photon. Oh no, that couldn't possibly happen. Yeah, it could possibly happen.
So this double slit experiment has huge consequences for our model of the universe. And it was very surprising the first time.
It is the silly part of your model goes loop-de-doo because you came up with a gremlin answer to why there's this phenomena. The simplest pattern in the universe, you decide it's always caused by wave interference. Could never be caused by just an angle deflection. No, that's not possible. No, you committed yourself to an angel theory, and then you just started building more and more silly angel-y stuff. Well, let's make a dark angel, and then, we'll make, when the angel accidentally, flies too fast and crashes into the earth, he'll turn into a holy ghost. And then all the Holy Ghosts, we have to make some sense out of this story. So, somehow all the Holy Ghosts converge into one Holy Ghost, the Holy Ghost, and the Holy Ghost sits there in between Jesus and God. I mean, it's just a religion.
time it was done. Physicists are still grappling with this question today and have come up with many interpretations.
Yes, many silly, just completely silly possible explanations. Just as bad as gremlins, just as bad as pixies, just as bad as Sasquatch did it. I mean, they're just as silly as an explanation as you can frickin' get. Just let me open my imagination. Maybe I'll take some drugs or something and come up with the stupidest, wackiest, dumbest theory possible. The more wacky, the better. And then we'll all vote on it, okay? And because we're all basically religious kooks in fake reasoning, rational person garb. You know, you're all the blood of religious nutters. You're jumping to the wackiest theory possible. Give me the wackiest theory possible. Ones with worms in it. You know, wormholes and such.
Of quantum mechanics to try and explain these results.
Yes, garbage, and many others, he says. So look, we do understand. The video said we do understand. And again, we have many silly explanations and then many other silly ones on top of that we don't even talk about because, yeah, they're so embarrassing.
And explain how reality actually works. Okay, let's go back to the wave function. We can now use this picture to explain other features of quantum physics that you may have heard about.
So they're using it to explain the simplest pattern you could possibly make in the universe, on, off, on, off, on, off. So far, it's really accomplished a lot, hasn't it? Oh, that's brilliant.
So this is just one possible wave function for an electron, but there's many others, like this one, for instance. This says that the electron has a probability of being over here and a probability of being over here, and very little probability of being in the middle.
Yes, well, which is also just bullshit.
This is perfectly allowable in quantum physics, and this is where the phrase things can be in two places at once comes from.
Yeah, anything is allowable in mathematics. So again, you're just, not anything, but so again, it's just, so he's calling it quantum physics. It's not quantum physics, it's just some sort of, made up structure that has to take some account for what the actual facts are, in the sense that, yes, we have effects that we know are effects, and they're just coming up with any cobbled together bullshit to explain the effects. And so they just invent, again, I mean, isn't it kind of easy if I can just invent invisible man? Isn't that what dark matter is? It's just invisible man, special little hands that push stuff. You know, I mean, and that's all they're doing. These are just invisible man, virtual, hey, the virtual photon did it. I can just borrow the photon energy from the nothing. I'll go to the empty hole and pull a big pile of money out of it, and then use the money, and then I'll pay the money back to the empty hole. I mean, that's their logic.
This is known as superposition, which comes from the fact that this wave can be made by adding, or superimposing, these two waves. The word superposition just means the adding together of waves. We already
No, it doesn't. So that's just more nonsense. Okay, the word superposition comes up because forces radiate a certain way. If I have two light bulbs and they're shining light, the light doesn't interfere with itself. The red photons don't hit the green photons. They actually have to go to a surface and hit the surface. The force doesn't interfere with the force. That's superposition. The superposition means you can add it up because the actual things have their own effect. So they used the word originally for gravity because gravitational bodies obey this superposition law, in the sense that each one has a force. The forces don't cancel in any real sense. They can only cancel when they hit something. I have to push the actual thing one way, and the other force has to push it the other way. The forces can't push on each other and cancel. They actually have to affect the thing.
Saw this in the double slit experiment. And it's not really a very special phenomenon. You can even see superposition by dropping two pebbles into a pond where the ripples overlap. Now for
and I could drop one pebble into a pond and I won't get any interference pattern. So again, interference has nothing to do with common wave function. So you have one experiment that confirms your bibble, and then the other experiments with one or multiple slits doesn't confirm. So you just sit there and quote mine the evidence, because that's what a good scientist does, is he ignores the evidence that says he's innocent and he just pays attention to the evidence of guilt. That's what a good scientist does, is cheat.
Entanglement. Let's say two electron waves meet. Their waves interfere with each other and become mixed up. This means that mathematically we now have one wave function that describes everything about both electrons, and they're inextricably linked, even if they move far away from each other.
And this is all just made up, so I mean, what the hell? They have absolutely no evidence any of this crap exists. This is just so fringe. And he's talking about this is what quantum mechanics was, let's say, 30 years ago, and it wasn't.
The measurement on one of the particles, like measuring if it's spin up or down, is now correlated with the measurement on the other, even if they move billions of miles.
Okay, particles spinning, these are all point particles. They can't spin. The spin would be irrelevant unless they're in some medium that can somehow feel the spin, somehow be affected by the spin. Just more nonsense, a concept that doesn't really exist, a made-up aspect. So because they have an experiment where they get an effect and they again misidentify the cause, just like with the two-slit experiment, simple. It's obviously an angle deflection, but no, let's make it more complicated than that. And they did the same thing in experiments where, okay, an atom goes up or an atom goes down, and they're assuming that something has to be spinning on the atom to be causing that, when no, the atom could just be bouncing, and it leaves the bounce going up or going down, right? I mean, if a basketball player is bouncing a ball down the court, right, and we're going to randomly freeze the frame, right? The truth will be is that the basketball 99% of the time will either be going down or it'll be going up. Those will be the two choices. The only two choices. There won't be any part where the basketball is going straight. It's going to be either going up or it's going to be going down.
Away. Einstein was very uncomfortable with this idea because if you measure one of the particles here, you instantaneously know what the other.
These graphics are just horrible. I mean, it's not even close to looking like Einstein. But anyway, this is like his nephew or something. With a hooker in between somewhere. So again, yeah, obviously Einstein was, I have to give him credit. I mean, I think he hated his own theory. 2 years before he died, he said, "I've been studying photons for 50 years and I haven't improved my understanding one iota." So you can see he didn't understand this shit. So again, this video started saying, we do understand. No, Einstein 2 years before he died says, this stuff is really fucked up. I don't get it. I don't think he liked what they had turned his bent space into. I don't think he liked what they had turned black holes into. I don't think, the whole singularity. I don't think he liked this idea of unlimited mass bullshit, infinite wells. I don't think he liked any of that crap. And he clearly didn't like this whole fluffy, no, the universe does random things. God plays dice with our dice. So it's like God rolls dice to decide how to roll dice, and then it's like there's this, yes, let's randomize something that's already random. Yeah, I think he thought that was not only redundant, but stupid.
Will be, even if it's billions of miles away. And that's got a sort of whiff of faster than light communication, which is not allowed by the theory.
Well, no, I don't think that's the only reason why. It's got a whiff of that, but it whiffs of a lot of poo. It whiffs of a lot of stinky ideas. It's not even that it's faster than light. It's through what magical mechanism? Oh, so we're living in this universe with all this complexity, and the truth is the little universe is even more complex because it has ESP. Photons can read each other's minds. I mean, please, the simplest things in the universe, and look at all these special powers they're giving them. And now they have this special power. I have these strings to my little heart. My little photon heart has little strings to my little twin. I mean, what? No, I think he said, oh, look, we've been silly, but let's not be ludicrously silly.
Relativity. But it turns out you can't actually use this to communicate information because the measurements...
Oh, it just turns out that we have a magical catch-22 bullshit rule that says somehow they're entangled, but not really. Yeah, that's what their theory is. They're entangled, but not really.
Give you random results. But the fact that they are correlated means that somehow there is a link that stretches over that distance. This is called non-locality.
Right, and they still haven't proven that the explanation isn't in the fact of their creation. The moment of their creation is left and right-hand glove. They still haven't proven that's not the fact.
Quantum tunneling. Quantum tunneling is where...
Oh, now he's getting into real wacky crap. Just absolute nonsense. So this is the whole freaking silly idea that I can jump to the future. I don't have to go 2 + 2 to get somewhere. I don't have to actually travel the distance. I can just magically go from this side to that side. I don't have to go any distance. So now we have photons that can spontaneously and instantaneously transport themselves. So why don't you call it quantum transportation?
Where particles have a probability of moving through barriers, essentially allowing things like electrons to pass through walls. When a wave function meets a barrier, it decays exponentially inside the barrier. But if the barrier is narrow enough, the wave function will still exist on the other side, meaning that there's a probability of the particle being found there when a measurement is made. In fact, the only reason you're alive is because of quantum...
Oh, bullshit. The only reason why you're alive is because of this crap? Nonsense. Absolute lying propaganda bullshit.
Quantum tunneling in the sun, which makes the sun shine. Protons normally...
Again, they haven't got that down. That's why they can't make cold fusion. They can't even make hot fusion. So let's not pretend they understand every single thing that's happening inside of the sun. And again, so this is just such, it is such exaggeration, preposterous exaggeration. They have a little bit of data and they create these complete exaggerated stories. This gigantic fish story, okay? This is just a Jonah whale story. Again, just this smells so much of religion, exactly what religion does. Oh, Jesus gave a poor man a cracker. And then it turns into this story where he fed 6 million people with 4 fishes or some other kind of crap. This is just a preposterous exaggeration.
Repel each other, but they've got a small probability of quantum tunneling into each other, which is what turns hydrogen into helium and releases fusion energy.
See, they don't even understand that how the sun is pressurized because they don't have a force for their gravity. So they don't even understand that the sun is hot because of the gravitational pressure, because of the amount of pressure pushing everything together. They don't even understand how gravity actually works, because they don't understand it's an energetic force. So they don't understand why protons are able to be next to each other inside of a nucleus, because they don't even understand that, oh, if you have an electron between 2 protons, the protons can get really close because the electron lets all of the force that's reflecting off of protons out. So they think it's a really strong force that's pushing them together, when no, it's absolutely no force at all that's pushing them together. There's no pressure between protons. That's why they're so close together. They're not being pushed together by a huge giant force. No, they're being pushed together by a normal amount of force, because they're releasing the pressure between them through the electron. So they don't understand how this physics really works. They're just made up all of this crap, and it's wrong. This is a wrong description of the reality. Now again, you don't need the right description if you know what the effects are. So again, we're talking about causes, and you know, all you really need to do to make a nuclear power plant is to understand the effects, to understand, oh, okay, if I put a bunch of radioactive isotope atoms next to each other, they'll decay faster. I mean, that's all you have to know, is that they'll get hotter. The more I put next to each other, the hotter they'll get. Oh, okay, there, I can make a nuclear power plant now. So again, you don't need to know any of this crap. So they're pretending that the real world is somehow made out of this knowledge. No, the real world's made out of the knowledge that, you know, when a piece of wood is burning, the chemistry is changing. It does this fire thing, which is a very intense, okay, decomposition of atoms, and it can make my skin burn.
All life exists on Earth because of energy from the sun.
I mean, just the more, all life on Earth, blah 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 blah. Yes, right. The radiant energy, not the nuclear energy.
Except for life around hydrothermal vents. Now onto the Heisenberg uncertainty principle. I said at the beginning...
Yes, except for the life around the vents. And when is the life around the vents being created? Right? Oh, it's by the same pressure. That's right, because the Earth is hot because of gravity. The inside of the Earth isn't hot because sunlight hit it. The inside of the Earth is molten because of gravity. Because it's absorbing energy from both directions, all directions. And the bits are moving. And they're moving in opposite directions, which means they'll end up doing all kinds of circular crap.
At the beginning that this wave function contains all of the information like position and momentum of the electron. We just have to do some maths on it. The position is given by the...
We have to do some maths. So more of these foreigners and their silly freaking verbiage. Maths. Math.
Amplitude or height of the wave. And the momentum is given by the wavelength of the wave.
So again, more nonsense, right? So again, the momentum of cannonballs is how far their frequency is. No, the momentum of the cannonballs is their velocity and their number. Okay, you add up the momentum based on how many cannonballs.
But for this specific wave, the position gives us a probability distribution, so we don't know exactly where the electron is. Also, there's an uncertainty in the momentum, because this wave is made of many different wavelengths.
So again, this wave, there's no wave, it's just the wave, you know, again, their model is that there's this concept of charge that works kind of like gravity, except it does repulsion, and that we have these atoms that are in balance, and yet they're saying somehow these waves are in balance. This whatever this is, whatever that represents, again, it's just a mathematical symbol. It's an abstraction, as he called it before, and he keeps drawing it like it's a real thing, like this is somehow something to do with the real physical universe. The real universe looks like that. No, the real universe looks like that's a clump. That's the reality. The electrons are in positions, photons hit them in their positions, and the electrons move their position, and the photon moves its momentum. It's deflected. That's the reality. That's the Feynman diagram. Why don't you do Feynman diagrams instead of this gibberish? Because at least that looks something like reality.
We can reduce that uncertainty. Let's have a wave that only has one wavelength, so a sine wave. Now we know the momentum exactly because the wavelength has a single value. But look at...
So again, it's just nonsense. It has nothing to do with momentum. We know that the rays, your wave has a ray length. There's a certain amount of light that comes out of an atom. You know, there's a certain amount of that photon.
At the position, there's an equal probability of the electron being found anywhere in the universe. Okay, let's do the opposite. Let's make a wave...
Well, obviously that would be idiotic to say there's an equal probability. So anything that tells you there's an equal probability has to be fundamentally retarded. I mean, that's just gibberish. That's can't make any sense to anybody with any brain. Okay, so they say Heisenberg uncertainty principle. Again, there's no principle here. There's no law here. There's no rule here. This is just a measurement problem. We can't see it, so therefore we can't identify what's happening. But there's absolutely no frickin' law that says when we do know, somehow the universe is going to say, you can't know, and so I'm going to make it go wackier. I mean, it's just so silly.
Wave that has only one position. Now we know exactly where the electron is, but what's the wavelength of this wave? Now the wavelength is very uncertain. Basically, only a sine wave gives you a precise momentum. And any wave that isn't a perfect sine wave, you have to build out of multiple different sine waves. And each of those multiple different sine waves has got a different wavelength, and hence you have a range of the possible different values of momentum for the particle. This is Heisenberg's uncertainty principle. You can only know certain things precisely, but not everything. Either you've got a definite value of momentum, and don't know anything.
There's no rule against it. They're the smallest thing in the universe. Obviously, we can't sit there and take videotape of them. We can't bounce photons off of photons to see photons. So yes, obviously, we can't know, but there's absolutely no reason to believe there's any rule of the universe that we can't know. No reason to believe that at all.
Anything about position, or you know the position very well but don't know anything about the momentum, or you're in some intermediate state. And this isn't a limit of our measuring apparatus, this is a fundamental problem.
See, he just said it. this isn't a limit of our measuring apparatus when clearly it is. Okay, that's clearly a fact. We can't measure it. That's clearly a fact. No theoretical way to measure a photon, to interfere with a photon in a benign way. No theoretical way to do that at all. Nothing. No theory that makes that possible. And yet he knows it's not the answer. That's not the reason. There's no way you can rule that out as being the reason. No possible way you can rule it out, because there's no possible way for you to demonstrate that, no, I can't actually invisibly touch photons, okay, and sense where they are without disturbing them. No, you can't do that. And you know it. Oh, just amazing, this declaration that somehow we have eliminated the other rational possibility. The most rational way of describing why there's this effect. The most rational reason why we can't understand the effect is because we can't see it. That's why we can't understand it. The cause is invisible to us. That's the most rational reason we don't understand something, is because it's invisible. Amazing.
Property of the universe. And finally, where does the name quantum come from? Well, a quanta is a packet of something, like a chunk of something. And
right. It's just idiotic. No, a quanta is a Plankness. An amount. So let's not pretend it's just any kind of clump is a quanta. No, the idea is that it comes in that configuration, that it's a constant clump, amount. All right, that's what the word really means. And it has nothing to do with no wavy crap, which implies nothing like that at all. Waves lose energy over time and distance. The energy is dissipated through making the wave. So this has nothing to do with anything called a common wave. It has to do with some kind of new thing that you've invented. You shouldn't even be allowed to steal the word wave unless you're going to admit there's an ether or jello or some kind of mush that's vibrating. So until you have the balls to actually own up and say, yes, I believe in ether, okay, quit pretending it could be a wave. A wave in what?
One of the first quantum effects people saw were atomic spectra, which is where atoms give off light with specific...
Oh, just more nonsense, right? Yes, they give up, they have a standardized frequencies inside of atoms, which you would understand to be the distance between the electrons, the amount of pressure the electrons are under. So the more pressure between the electrons, the higher the frequency photon will be popped out. The lower the pressure, the longer the frequency line would be in terms of the light spectra. Wow, huge surprise. No, not a surprise at all.
Specific discrete energies. It works like this. Imagine a string that's tied at both ends, like a guitar string. If you pluck it, only certain waves can exist because the ends are tied down. In this situation, we say that the wavelengths are quantized to certain values. The same thing happens if you tie the ends of the string together because the waves have to match up. They can only vibrate in certain restricted ways. And this is what's happening to an electron in an atom.
So they say, see again, they don't know any of this stuff. And there's obviously plenty of ways you can describe that. It's just, I could take billiard balls and bounce them back and forth. And if they're allowed to bounce back and forth, and they're connected to other arrangements, like ping pong paddles and ping pong balls. I take a bunch of paddles and I put balls bouncing between them, that have energy, and they'll just keep moving the same speed. Obviously, any speed changes, any wavelength of one is going to be affected by the wavelengths of the other, and in a sense all the ping pong balls eventually will move in unison. They'll have a resonant frequency, so they will create constructive, they can exist as constructive impacts, and anything that's destructive, that is when the ping pong paddle is moving this way and the ping pong ball, an extra ping pong ball is coming this way at the same time, that it's going to destroy any of the momentum in that direction. Destroy, and I mean convert it.
Electron wave is constrained by the atom and quantized to certain wavelengths. Short wavelengths have got a high energy, and long wavelengths have a lower energy. This is why the light emitted by an atom looks like a barcode, because each bar of light corresponds to an electron jumping from a wave with a high energy to one with a lower energy, and at the same time emitting a quantized photon of light when it does this.
Yes, it's a certain amount of pressure at certain depths of the atom. So the electron's distance, just like with magnets, you can arrange things with magnets and blah 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 blah. There's a certain amount of pressure on certain magnets and a certain amount of pressure on other magnets, depending on their location.
So the light from an atom is quantized to discrete packets of energy. Okay, so that's all the basics of quantum physics. Here are some technical notes which aren't essential to know, but pause the screen now if you're interested in a little bit more mathematical detail. So to
yes, again, more nonsense, just really, this is the abstraction part. So yes, we can take an effect and we can turn it into a formula. We can formalize the effect to certain variables. Now, we don't have to know exactly what's causing the variables. We just have to know that they're the variables that create the effect. So we can know that the frequency of the light will change the pattern creating the two slit. And we can know that if we change the width of the slit, that can also change where the light will go. So we know we have two important variables in deciding what affects the thing. I would argue there are others, and they don't even search for those. Probably how thick this slit is. I mean, its depth this way.
Round up. In quantum physics, objects are described with wave functions, but when we measure them, what we see are particles. So this leads to particle-wave duality, and also the measurement problem. And the consequence of these wave functions...
Right, and this is, he's saying this is, he's like, again, let's remember how he started the video. Oh no, we really do understand. And this is their understanding. This just made up crap. When we know the effect is a really simple effect. The photon goes 3 degrees, or the photon goes 6 degrees, or the photon goes 9 degrees. Really simple effect. And they need all of this to describe it.
...the quantum phenomena of superposition, entanglement, quantum tunneling, the Heisenberg uncertainty...
Right, and look how these boxes, this whatever, this flow chart doesn't flow, right? There's no A, B, C, D, E, F, G, H, I. There's no order here. Oh, step 1, step 2, step 3. No, they're just a bunch of disconnected fables. Well, there's the Gremlins do this, and the Pixies do this, and the Tinkerbell and her friends do this, and blah blah blah, and they have the whole disconnected bunch of crap that really can't be Venn diagrammed or or in any way connected to each other realistically at all. Completely no continuity in it at all. And he says, oh yes, I'm sure you understood all of that crap. This completely broken pile of disconnected ideas and concepts somehow equals I understand. No. This is the diagram of not understanding.
Principle and energy quantization. So if you understand these things, you've got a good basic understanding of quantum physics. Despite its reputation, I think that quantum mechanics isn't too difficult for most people to get the basics of what's going on.
So again, get the basics of what's going on. We do abstract math and then call ourselves understanders. We invent concepts like magical bent geometry and the virtual photon. Don't you get it? It's virtual. Don't you get that? Shit. And it's waving when it's not a wave.
In the past I've relied on analogies to try and explain it, but here I've just described what's actually going on, which I think might be more helpful.
Oh, bullshit, you actually going on. So again, he uses these words. I'm describing what's actually going on. It's a multiverse, or maybe it's Copenhagen, or maybe it's radar, or maybe it's de Broglie, or maybe it's a... Yes, you accurately describe the fact that you have no frickin' clue.
But if you've got more questions, I'll be on the comments below, so ask away.
No, all I got is ridicule. This is just such propaganda. Again, to claim that this stupid, idiotic pile of mushy garbage as causes has anything to do with the fact that we conquered effects and that we can build campfires. I don't need to know no quantum mechanics. I could probably successfully shoot a rocket into damn space, and I don't have to know any of this crap. All I have to know is that hydrogen blows the fuck up when I put it with a bunch of oxygen. Shit, that oxygen's one hell of a good oxidizer. That's all I have to frickin' know.
For me, the weird thing about quantum physics is that on the one hand it's incredibly accurate and predictive.
No, it's not incredibly accurate. That's the whole point. You just don't pay attention to the non-accuracy or the contradictions it creates. A single slit creates 2 waves. 2 slits create 2 waves. A single slit creates two waves. The two slits create two waves. Oh yeah, that doesn't make any sense. How come the pattern is bars and when it's photons, when it's supposed to be gradually getting light and dark, gradually light and dark? How come some of the experiments, it looks like little balls on the pattern, and then other experiments it looks like little rectangles? And then how come when it's a diffraction gradient with a whole bunch of slits, it looks like actual images? Yeah, there's actually images in the different locations. Actual images of what went into the slits. How does wave theory explain actual images going to the locations? It doesn't. Random don't do that. Random don't do actual images to locations.
But also it's got giant holes in it, like the measurement problem.
Right, yeah, you got giant holes in. Now you're conceding that the measurement problem is a real problem. Before you said, no, we know that's not the cause. That's what your words. You said, that's not the cause. The measurement problem is not the reason why it's happening. You said those words, and now you're conceding there's something called the measurement problem. I mean, can't you even get your fable right? Can't you read your Bible correctly?
Just don't understand. So we can wonder, will we ever actually understand quantum physics?
Alright, so he started the video by saying, we do understand, Feynman was wrong, that's an exaggeration, blah, 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 and he's just explained how, now look, it looks like a pile of shit, right? Look, I just showed it to you. You can smell this, can't you? Right? You're a fair cop, right? You know what I just did here is, that's a stinker, right? You know that's what I just did. This ain't roses.
Physics, or is it just too abstract for our human brains to comprehend?
Oh, there we go. It's too abstract. The reality is abstract and weird and fluffy and mushy. Even though every bit of our lives, no, it's really simple. There's a fire. I put my hand in it. My hand gets burned. I don't have no fucking ESP. I have a twin sister. I'm not fucking entangled for some reason. How come? I have a twin sister. I mean, yeah, I sympathize and we kind of know each other a little bit, but you know, I can't telepathically know what she's doing or any of that crap. How come? What a big ripoff. Here we are in the big universe, big fancy complicated things, and we can't do any of these quantum fucking powers. How come we don't have any of these superpowers? Such crap.
Well, I hope this video has helped you understand a little bit more.
Oh, there. So I hope it's enabled you to understand. Instead, what you should say is, I concede, okay, you really can't trust us. Give us a second and we'll just make up some kind of invisible man. That's all we do, okay? Bent space, virtual photon, dark matter, you know, subliminal virtual speeds, entangled mind-reading photons. I mean, we'll just make up complete crap. So yes, give us a little tiny rope and we'll go running right off into fantasy land. We'll go right down into the frickin' Wonderland and start talking to caterpillars. He's conceded the truth. My smoker broke. Temporarily broken.
More about how quantum physics works. And thanks to the sponsor of this video, Brilliant.org, who have just...
Oh, so Brilliant. Yeah, they're Brilliant's doing all of these shitty physics people sponsoring all of this shit physics. So it's not Brilliant, it's propaganda. Propaganda.org.
Launch their daily problems, which you can dip into if you've got a spare 5 minutes each day. Each problem teaches you some interesting facts that you can then use to solve
Yes, more propaganda, propaganda. Oh, look at our theory has proven everything. We predicted that, you know, Donald Trump was a lying sack of fucking shit. No, you didn't even do that. Your quantum mechanics totally failed you. Ugh, fucking idiots. I hate this planet. Alright, well, we're not going to play the commercial. So, enough of a video. And such. I'll just finish it this way. So, till next time and such.